Hi guys, let's start off with our first set of notes. But first, a little math joke. Let's review some geometry. So here we go. Why are obtuse angles always sad? Because they're never right. Haha, get it? Right angles, obtuse angles are never right angles. All right, anyways, let's get started with the first section of Honors Algebra 2, Section 01, which is representing functions. A little bit of this will be review. However, there will be some new terminology and notation. So let's fill in the blanks together. A blank can be represented by a set of ordered pairs, a table, a graph, or a mapping, and that is a relation. The blank of a relation is the set of all first coordinates, all of the x values. So hopefully you remember this vocabulary word, but the domain is what is represented with all x values, or those first coordinates. Therefore, what represents the y coordinates? That's the range. Hopefully you remember seeing those vocab words before. But just remember, domain is our x's, range is our y's. Now, the coordinate plane is divided into 4 quadrants. And you can see to the side here, we have a coordinate plane and our quadrant names. So quadrant 1 is in the top right, quadrant 2, top left, quadrant 3, bottom left, and quadrant 4, bottom right. We go in counterclockwise direction. Lastly, a function is a relation in which each element of the domain is only paired with exactly one element of the range. Okay, so our x values cannot repeat with different y values. Each x goes with just one y. A relation, however, can be any ordered pairs. All right, so let's look at some examples here and how we represent domain and range and so forth. So in the first example here, we have a function. And this is a function because, as you can see, our x values, they don't repeat with different y's. So the x value of 2 is just paired with 1. I don't see 2 showing up again. X value of 5 is just paired with 3. I don't see 5 being paired up with anything else. And 8 is only being paired up with 1. So that's why this is a function. Now we want to represent the domain of this. So we have 2 ways to write: set notation and interval notation. So for set notation, when I'm talking about just the domain here, we're literally just going to use these braces and represent the x values. Oftentimes we'll put them from least to greatest. So we have an x value of 2, an x value of 5, and an x value of 8. So there's our domain. Interval notation is a new notation that you probably haven't seen before. And when we're just given a list of ordered pairs, there isn't an interval notation form. So we would just use that set notation listing those x values. However, what if we have a lot more than just a few set points? So in example 2, it says if the domain is all values greater than or equal to -4 and less than 6. So that's an infinite amount of values, right? Greater than or equal to -4. Sorry, not an infinite amount, but a ton of them, right? We could have -4, -3, -3.2, -3.017, lots and lots of values. So we're not just going to list set numbers. We need to use our greater than and less than symbols. So for set notation here, recall domain is our x's. So we're going to use those braces just like above. But instead of just listing numbers, we're going to have our value x because we're domain, and we use a bar to represent such that. So this is saying x such that, and we're literally going to write this statement that they gave us using our inequality symbols. So we're greater than or equal to -4 and less than 6. Okay, so again, greater than or equal to, we have the line underneath, a less than symbol, no line underneath. And again, I'm using the variable x because, again, we're talking just about the domain. So this is our set notation. Again, braces, and this time x such that x is greater than or equal to -4 and less than 6. So what is interval notation? Interval notation is going to use parentheses and brackets. So I'm going to write it out for you and then explain it. So for this one, we're greater than or equal to -4. So it's all the values starting at -4 and going all the way to +6. So wherever our starting value is, that number goes first. Then we use a comma to express we're going to continue on until our end value, which is 6. Now notice here what I'm using. I'm using a bracket and a parenthesis. Why? Well, brackets mean, and I'll just jot this down for your notes, means that the value is included. So -4 is included because we said greater than or equal to. However, we use a parenthesis when the value is not included. So less than 6 means that we want to get really close to 6, right? 5.9999999. So we don't want to end at 5, but we aren't going to actually include 6. So the parenthesis means the value is not included. Okay, so set notation uses braces. Interval notation uses our brackets and parentheses. Now, if the start point and end point were both not included, then we'd have two sets of parentheses. If it was both included, we'd have two brackets. All right, let's keep looking at some more examples with this notation. So the next one we have is the range. So in this case, we're going to use our similar notation as we did above, but remember, since we're range, we're talking about y values. So we have all values less than 7 or greater than 10. So for set notation, we use those braces. Instead of x this time, we'll use y, such that, and it's all values less than 7, so y is less than 7, or y is greater than 10. So again, for set notation, pretty straightforward in the fact that you just take the statement and write it using our inequality symbols. For interval notation, again, we're going to use those parentheses or brackets. Now this one is a little bit different because we're talking about all values less than 7, not in between 7 and 10. So if I'm talking about all values less than 7, that means 6, 5, 4, 3, 2, -1,000, right? -1,000,000, all the way to -infinity. So here's how we'll write it, and then I'll explain it a little bit more. We're going to use a parenthesis. We're going to use -infinity, and it's all the values from -infinity up until 7. It's not included, right? We're just less than 7, so since I'm not included, I'll use a parenthesis, not a bracket. Now, when I have a break in our values, right? For instance, 8 and 9 aren't included. We use something called a U to represent the union because we have two groupings and our answer needs to be both of them together. So we have from -infinity to 7 that represents all values less than 7. And now we want to represent all values greater than 10. So we take a break and then we pick back up at 10. And again, 10 is not included. We're greater than 10. So I'm using a parenthesis. And all values greater than 10 means 10, 11, 12, 13, 14, all the way to +infinity. So if you've never seen these infinity symbols before, sideways 8s are infinity symbols. And notice here, I'm using a parenthesis. Okay, so I'm just going to make a note that infinity symbols will always have parentheses. And this is because infinity is not a tangible number. Sorry, I ran out of room there. Is not a tangible number. We can't actually grasp it. So it's not technically included. Okay, if it went all the way to -1,000,000 and it was included, we could use a bracket, but infinity isn't tangible, so we always use a parenthesis. Okay? All right, number 4 says if the range is all values less than or equal to 7. So I want to give you a minute to pause this, try this one on your own, and then go ahead and resume with play, and I'll walk you through it. Okay, so if the range is all values less than or equal to 7 for set notation, we use our braces. Again, it's the range, so we use y such that, and all values less than or equal to 7 is simply less than or equal to 7. Now, interval notation. If I'm less than or equal to 7, it means we're going to start at negative infinity and go all the way to 7, and this time we're equal to, so 7 is included, so I use a bracket. There is not a union because there's not another set of values, it's simply just the ones from negative infinity to 7. Okay, let's look at some more ways to represent relations and functions. So for these problems, we're going to look at the way to represent it. We're going to determine if it is a function or not, and then state the domain and range. So I will do some of these with you, some parts of them with you, let you finish other parts, and then there's a couple at the end for you to try completely on your own. So our first one here is just a set of ordered pairs. A way to represent a relation in a function can just be listing out the ordered pairs. So we want to look to see if this is actually a function. So recall, a function means that our x values cannot repeat with y values. So we have 2 being paired with 1, okay? -3 being paired with 4. So far, so good. Our x values aren't repeating. Then we have 2 being paired with 5. Uh-oh, right? Here, our x value of 2 is being repeated with different y values. So this is not a function. What is the domain? Remember, with our ordered pairs, we can only use set notation, so we just list them. And again, we try to list them from least to greatest. Domain is our x value. So that means -3, 2, and 5. You do the range. All right, now another scenario is a mapping. So we have one bubble represents our x values and one represents our y's. So let's see if it's a function. Are all the x values just being paired with one y value? So our x value of 3 is just with -1. 3 does not be paired with anything else. 0 is just with 0. -3 is just with 0. And -6 just with 2. So this is a function. Even though we have y values being repeated, right? The 0 and the y is being repeated, that's okay. Ranges can repeat. But our domains, we can only have a single arrow off of each x value, which we do. So I want you to list the domain and range here. Again, we just have ordered pairs, so you're just going to use set notation. Okay, a table. Table is another way to represent a relation or a function, very similar to the mapping. Our first column represents our x values, our second column represents our y values. So let's look to see if this is a function. -1 is just showing up once, 0, once, 1, 2, 3, just showing up once. So this is a function. Our domain here, I'll do it with you so you can kind of see if you had done the mapping correctly. Our domain is just our x values, so we list them from least to greatest, which is super straightforward because they're already listed. Again, because this is just a set of ordered pairs, we're only using set notation. We're not using our interval notation. Our range will be our y values. Again, we'll try to put those from least to greatest. So the smallest number I see there is 3, a 4. 4 shows up twice, but I only need to represent it once. Then we have a 5 and a 7. Okay, again, just set notation, no interval notations. We don't want to say the domain is from -1 to 3 because none of those decimals are actually included. It's actual set points. All right, let's look at number 4. So for number 4, we want to know, is this a function? Now, what we can look at, we can see our x values being repeated. So for example, let's start at like -2. Do you see right here, -2 is being plotted right here. Is -2 being plotted anywhere else? No, we don't see that. Same thing, how about like -1.5? It's being plotted just once. And if you recall, and we'll look at this even further in a next chapter, is the vertical line test. So this graph passes the vertical line tests, which means if I pass a vertical line through, it only hits at one point. And we can see that none of these x's are repeated. They're only plotted once. Again, the x value of 4 is simply just plotted right here. It's not plotted multiple places. So this is a function. Now, this time around, there's a ton of points plotted because we have these arrows, right? So we can use set notation and interval notation. So let's talk about our domain. It's our x values. So notice here, we approach this x value, and I'll use a different color. We approach this x value of 2, but there's actually no points being plotted at 2. If we go to the left, though, right, this arrow is saying keep on going, which means all of our x values to the left will be plotted. Well, all of our x values to the left means to negative infinity. So what this means is that we're going to have all values that are less than positive 2, and then the same thing, we're going to the right forever, so all values greater than 2. So we can write that as the following: x such that x is less than 2 or x is greater than 2. Simply, another way to write that is x such that x can't equal 2. Everything else works. Now, what does that mean for interval notation? Remember, interval notation is using those parentheses and brackets. So let's start at the very beginning to the left. We said it goes on forever to the left. So that means we're going to go to negative infinity. So we'll start at negative infinity. Remember, infinities always use parentheses. We keep on going, right? This graph is plotted up until that x value of 2. But 2 is not included, so we use a parenthesis. Then we have a little gap there. So we use that union symbol, and we pick back up everything to the right of 2. So we start at 2, and we're going to the right forever, which brings us to positive infinity. So that's our domain. Let's now look at the range. I'd encourage you to hit pause and try this one on your own and then check your answers. So for range, for our set notation, we're going to have y. And this time our y values are up and down. So we're going to look what's the lowest I go, what's the highest I go, are there any breaks? So the lowest I go, we can see that there's an arrow. It's saying we're going to go down forever. So that means we're going to go to negative infinity. Now, we also go up forever. So we're going to go to positive infinity. However, there is a break in the graph, right? There is a break at the y value of 1. So what we need to do is we need to do it very similar to how we wrote our domain. We're going to have y such that y is less than 1 or y is greater than 1, but 1 is never included. That's the same thing as saying y such that y can't equal 1. Everything else is fair game. For our interval notation, it'll be very similar to how we wrote our domain, except for using a 1 instead of a 2. So the lowest we go is negative infinity, and then it increases all the way to 1, but it never touches 1, so it's a parenthesis. Then we pick back up, never touching 1, but everything close to 1 and going up forever to positive infinity. Okay, number 5. Number 5, our last way to represent our functions and domains is as an equation. Okay, so we had ordered pairs, a mapping, a table, a graph, and now we have an equation because any equation, remember, can be plotted as a graph. So that's what you really want to think about when you see equations is what does the graph look like? Well, this is in the form of y equals mx plus b, right? So this is a line. And you can even think about a quick sketch. So if we had this, remember, we plot our y-intercept, okay, that'll be positive 3, something like this. Our m is our slope, that's 2. So It's something that looks similar to this. When we have a linear equation, it's going to be a function. The only linear equation that's not a function is a vertical line itself. Every other line is a function. So we have a linear equation. Yes, it's a function. Now, what's the domain? Well, our domain is all the x values that work. If I look to the left, right, and to the right, that's our x values. And if I look to the left, I will be able to plot every single x value. This graph goes on and on, both up and down and left to right. So that means my domain is the following. In set notation, we could write x such that x equals all real numbers. That's our symbol for all reals. In interval notation, it means every number, so negative infinity to positive infinity. Our range will be the same thing. This time it's y. Y such that y equals all real numbers, or from negative infinity to positive infinity. Okay, so some of that is some new notation, okay, particularly when it's not just set ordered pairs. So I want you to give these two examples a try on your own, and then we will check those together as a class tomorrow.